to the channel. Today we are kicking off a brand new series that is Sales Foundation. In this video, we are diving straight into Unit 1, that is Software Engineering Foundations and the SDLC. Whether you are a student preparing for exams or an aspiring developer wanting to build a reliable system, understanding how software evolves from an idea into a massive product is crucial. We will cover the entire life cycle, requirements, engineering, and IEEE SRS standard. Hit that subscribe button and let's get started. So in this video, we will do our CS Foundation series of unit number 1 of Software Engineering Foundations and SDLC. We will cover evolution and impact, SDLC and models, Agile, Scrum, DevOps, requirements, SRS, IEEE, validation. What we will cover in unit number 1, that is first one is evolution and impact of software engineering. Second one is software development life cycle. Third is life cycle models. Fourth is functional and non-functional requirements. Fifth one is requirement gathering and analysis. Sixth one is SRS, IEEE standard writing and validation. So first is evolution of software engineering. So what do we mean by software engineering? It is the disciplined application of engineering principles to the design, development, testing, and maintenance of software born from code without process flow. In 1968, software crisis is there, in which NATO conference coins the term amid field over budget projects. In 1980 to 1990, OOPS and case tools, object reuse and early automated development tools. DevOps and cloud, continuous delivery merges development with operations. In next part, in 1970, structured programming is there, top-down design, modular code replace ad hoc coding. In 2001, Agile Manifesto. In 2020, AI-assisted engineering, copilots and LLMs accelerate coding review and testing. In this, we can see in 1968, first software classes is there, then structured programming has come, then OOPS and case tools has come, then Agile Manifesto is there, then DevOps and cloud has come, then AI-assisted engineering, all the AI materials came in 2020s. Real world anchor. The 1968 NATO conference on software engineering explicitly used the phrase software crisis to describe projects that were late, over budget, and unreliable, the founding motivation for the discipline. What are the impact of this all? Why it matters when software engineering fails? First one is Ariane 5, 1996. $370 million rocket self destructed 37 seconds after launch and unhandled 64-bit to 16-bit integer overflow reused from Ariane 4 without retesting. Knight Capital 2012. A bot's software development left old test code live in production, triggering runway trades $440 million lost in 45 minutes. Tharek 25, 1995 to 1997. 1987. A race condition in radiation therapy control software delivered massive overdoses, contributing to patient death. In next part, we will see what are the SDLC, that is software development life cycle. This is the important question for an MCQs What are the full form of SDLC? That is Software Development Life Cycle. Every life cycle model, waterfall, agile, DevOps, is an arrangement of the basis. SDLC is the universal roadmap from idea to a maintained working product. First is requirement gathering, second is analysis, third is design, and fourth one is first one is requirement gathering, then analysis, then design. Sixth one is development, deployment, and seventh one is maintenance. We will see fourth and fifth what it is there in this SDLC model. Fourth one is coding and fifth one is testing. So first is requirement gathering, second is analysis, third is design, fourth is coding and implementation part, fifth is testing, then deployment, then maintenance. Here's the software development life cycle. Next one is what are the waterfall model in this SDLC life cycle model. First one is requirements, second is system design, third is implementation, fourth is testing, fifth is deployment, sixth is maintenance. Strictly sequential, each phase must finish before the next begins. These are in the phase it cannot break, otherwise it will get an error in code or anything else. Best suited for fixed well documented requirements. Example core banking system upgrades or government defense contracts where scope rarely changes mid project. Pros and cons. Simple to manage and document. Second one is clear and milestone and deliverable. Third one is works well for stable scope. What are the cons of this waterfall model? No going back once a phase ends. Second one is working software seen very late. Third one is poor fit for changing requirements. What are prototyping model in lifecycle? That is build a quick working mockup so user can make a real system is engineered. Ideal when requirements are fuzzy or UI UX heavy. Gather requirements, quick design, build prototype, customer evaluation, and then refine. They are a loop until approved. Two flavors, throwaways. Prototype discarded after learning, final system build. Fresh evolutionary. Prototype is progressively refined into the final product. You can see two flavors and throwaways. Real world example is Bank's pilot clickable mock-ups of a new mobile banking screen with a focus group before writing production code. Cheaper to redesign pixels than rewrite a live app. In next part we will see spiral model. In a spiral model, we will see first one is objectives, then risk analysis, then formatting, then evaluation and review. Let's confirm this spiral model. First one is determine objectives. Second one is risk analysis. Third one is development. Fourth one is evaluation and reviews. Why spiral? This question can come because it combines waterfall structure with prototyping, feedback, adding an explicit risk analysis step before committing further budget. Real world example is large OS platforms and defense aerospace software. Example early Microsoft window releases used spiral style loops to manage massive technical risk incrementally. Next we will see V model. It means verification and validation. Every development phase on the left pair with a matching testing phase On the right, tests are planned as soon as requirements are written, not after coding. Means testing are planned as soon as requirements are written, not after coding. Means testing is not done after coding. Requirements analysis, then system design, then architecture design, then module design. In this, acceptance testing, system testing, integration testing, then unit testing, and then coding will be done. Real world example is medical device software, pacemakers, infusion pumps under FDA rules, and automotive ECU software use V model Riger. Every design decision has a pre-planned test to prove it's safe. What are Agile and Scrum? Agile delivers working software in short, repeated cycles instead of one long phase. Scrum is the most widely used Agile framework. In this, we will see product backlog, sprint planning, sprint 2 to 4 weeks, daily Scrum, sprint reviews, and then a retrospective. Core Scrum roles, product owner owns the backlog and prioritizes. Scrum Master removes blockers, guards the process, development team builds the increment. Real example is Spotify organizes engineers into autonomous squads running short sprints. ING Bank restructured into agile tribes and squads to cut release cycles from months to weeks. Next, we will see DevOps life cycle. Development and operations merges into one continuous automated loops. This is last phase. First one is plan, then code, then build, then test, then deploy, then operate, then monitor. Real example is Amazon deploys new code roughly every 11.7 seconds on average across its system. Netflix Spinnakers pipelines push thousands of production deployment per days, both rely on automated pipelines from the loops. Comparison. These are the models. These are flexibility and these are risk handling. Waterfall that is stable, well understood requirements, low flexibility and low risk handling. Prototyping is UI UX heavy, unclear requirements. Flexibility is medium and risk handling is medium. Spiral model in this large complex high risk projects. In this flexibility is medium and risk handling is high. V model is safety critical regulated system low and medium. Agile or Scrum involving evolving requirements and fast delivery in this. Flexibility is high and risk handling is medium. DevOps is continuous delivery or cloud native products in this high flexibility and high risk handling. Now, what are functional versus non-functional requirements? Functional. User can reset password via email or OTP. Second one is system generates a monthly invoice as PDF. Third one is admin can add, edit or remove courses. Fourth one is app sends a reminder before a due date. It describes capabilities and behavior, usually testable with a pass or fail use case. Non-functional requirements, pages must load within 2 seconds. Second one is system supports 10,000 concurrent users. Third one is 99.9% uptime SLA less than 9 hours downtime per year. All stored data encrypted with AES 256. Real world exam stakes is Amazon found every 100 meter-second of extra latency cost about 1% in a sales, a performance NFR with real revenue impact. What are requirement gathering and analysis? First one is interviews, second one is questionnaires, Third one is brainstorming. Fourth one is use case modeling. And fifth one is observation. Sixth one is document analysis. Analysis step. Prioritize with Moscow. Must have, should have, could have, won't have. Then run a feasibility study, technical, economical, and operational. Real world example is build a hospital management system means interviewing doctor, nurses, receptionists, and billing staffs separately. Each group's need different sometimes conflicting features with analysis must reconcile. Software requirements specialization. IEEE 830. The SRS is the contract between stakeholders and engineers. A single document precise enough to design, build, and test against. First one introduction, second one is overall description, third one is specific requirements, and fourth one is appendices and index. Introduction is purpose, scope, definition, or acronyms. Reference document overview. Second one is overall description, product perspective, main function, user characteristics, constraints, adoption. Third one is specific requirements, functional requirement, external interface, performance, design constraints, quality attributes, appendices and index, supporting diagrams, data models, glossary, traceability, and tables. Validating the SRS. Correct, complete, consistent, verifiable, traceable, feasible. Real world example is an e-commerce SRS that omits a load capacity requirement can pass every functional review and still crash on Black Friday. Exactly the kind of gap validation is meant to the catch via reviews, walkthrough, and prototype test case checks. Keyways from process to product. Software engineering exists because unmatched code does not scale. Real failures. SDLC phases stay constant. Lifecycle models just arrange them differently for risk, speed, or regulation. Third one is choose the model to fit the project. Waterfall or V model for stability and safety, Agile or DevOps for speed and changes. Grid requirements, functional, non-functional, and validate. IEEE style SRS are the foundation everything else is built on. So thank you. We have done this unit number one, all the concepts of SDLCs. In next part, we will do some MCQs question of this unit number one, which is important in your end term, mid term, or CAs. So till then, take care and do revision of all these concepts. Thank you. Have a nice day.